Okay, so we're back, and the next part here is before we start our design as usual. So we know a little bit about theory by now, but also the code, the concrete design manual. It has some uh, limits and clause that simply control the design of the column. Same as, for example, if you remember in beam design, are so many limitation from the code. We will go through the same thing in columns. Okay, so let me show you what the code says when it comes to the column design. First of all, there is something that you will notice here when we discuss the beam design. What was the reinforcement ratio? How do we estimate the reinforcement ratio? Can anybody, or does there anybody remember how do we estimate reinforcement ratio in beams?
AS over the area of the concrete.
Okay, so thank you so much. And explicitly, what is a concrete? What is the area of the concrete? Is it the width of the beam times the depth of the beam, or
The
we use the effective depth of the beam?
effective depth of the beam times the width of the beam.
Excellent. So now, is that the same thing here? The answer is no. In column design, please take a note, make it clear, box it out, do whatever it takes. Make sure that in columns, when we say reinforcement ratio, it's still the same. It's still area of steel, which is the vertical bars, divided by the area of the concrete. But in this case, we multiply the width times the depth of the section, not the effective depth, which means in the previous example, when I had eight 30M, and it was 500 by 500. In this case, the reinforcement ratio is 50, which is 8 bars times 700 mil square divided by 250,000 mil. Please take a note. And really, the difference here is area gross. It's the gross area of your section. Now, the thing is also here, do we have a limit on the reinforcement ratio imposed by the code? Yes, we do. So in the code, if you review clause 10.9.1, so it will tell you that the reinforcement ratio should be less than 8%. And the 8% is over there. Huh? So the 8% is over there. So this reinforcement ratio here, the maximum is 8%. Now, we'll talk about the minimum, but let's say for now, the minimum is 1%. So in any column, we should do reinforcement ratio anywhere between 1% and 8%. But the code on clause 10.0, I doubt that this is a right number, so please give me some time to check that one. But it is not 10.0. There is nothing called 10.0.2. Okay? But there it says, so this is correct statement. It says the column should be designed no more than 4%. And like explain for you how. How come it says 4% and 8%? Do you guys know that how we build columns? So let me show you how do we build columns. So how we build columns is let's say we have this floor here, and we have done the previous floor. So here is the previous floor. Okay, so that's the column of the previous floor, and we're trying to add another floor. I'm asking you how we go about this one. Look at this, please. So we have our rebar. We make sure our rebar extends beyond the level of the slab, just like so. And so those are called the column starters. Okay. So this projection of the rebar on top of the floor level, call them starters. And then the next floor, what we do is we bring another cage, and another cage will be here. Okay, will be this way. And so they have a kind of a splice, and simply we place our next column. So this dimension here, it's called splice. splice, and we will talk about the splice later in our course, probably next class. But the thing here is, if I'm asking you, if I add here 4%, so if those are 4%, 4%, okay, and in this column, I also have these bars are 4%. Let me ask you, on the splice zone, what will be the reinforcement ratio?
Um,
So if you take cross section here, if you take cross section here, let's say you will see 8 bars, and those 8 bars are 4% of the cross section. Okay, and if you take cross section here, you will see another 8 bars, which is a 4%. Let's say 4% of the section. I'm asking you, if I take a cross section here, what will be the percentage? The area of,
8%.
huh?
8%.
Will be 8%. And that's why there is no contradiction between the 8% and 4%. If you have a column that has one left that has no splice, then in this case, you're allowed for 8%. However, if you have this situation, it means either column, the top or the bottom, they have maximum of 4%, where at the overlap, we will have 8%. However, if you add 8% each, what you end up with, you end up with 16% in the overlap. Would you agree?
oh
Yes.
yeah, that's true.
And that's crazy, by the way. If you see a column that has, and we will see this in the numerical example, if you see a column that has 8%, that is so much reinforcement. Probably we use them in bridges. Okay. So thing is, really practically to avoid this problem at the splice, we should stick to the 4%. Okay. However, we are allowed to go to 8% only and only if your column is one left, there is no splice whatsoever in your column. If you have any running into this situation, it means you must limit each to 4%. So which means at the overlap is going to be 8%. And I can tell you 8% is kind of a forest of rebar, lots of rebar. And you guys know what happens if you have a forest of rebar. Can anybody tell me what happens? What's the problem?
Overly reinforced.
You know what? To be honest, like this is not an issue because column it is mainly under compression force, and they fail in a brittle way no matter what because the main force is compression. So there
Crack
is
then.
nothing we can do. There is nothing we can do to force our column to fail in a tension failure. There is nothing you can do.
So then
But
you,
really the
the
problem
column
here,
will crack.
excuse me.
The column will crack if you put too much reinforcement.
It's not cracking. It's about concrete finishing. You will have problem with concrete to flow in between because you have a very dense amount of rebar, and you have a problem with finishing concrete in this column. If you agree, are you following so far?
Yes, sir.
Yeah, I'm
Okay, so
following. I was just writing notes.
okay, because I don't see Gord, I don't see you. I see only the slides. I don't see if you're writing or so that's why I ask for confirmation. And I know probably some of you sometimes annoyed by me asking for confirmation that you're following, but it just I feel that isolated that I'm talking to myself. Okay, so
It just
the
takes me a minute to get from writing my notes to unmuting myself so that I can answer you.
totally understood. Thank you so much. So the next code clause, it's not 10.9.3, which is about minimum numbers of vertical bars. Minimum number of vertical bars. So I can give you the golden rule. The golden rule is the minimum is every corner in your column must have a bar. Every corner of the column must have a bar, every corner, which means if your column is a square or rectangle, then the minimum is 4. In my slide here, it says if your column is triangular, then use 3. I haven't ever seen a triangular column. But anyway, we typically see a square or rectangle, or sometimes we see circular column. But what happens if you have a kind of L-shaped column? L-shaped column, the rule is every corner must have a bar. In the spiral columns, we need 6 bars minimum, okay? So that's the minimum number of bars. Now, how about the minimum spacing? The minimum spacing between the rebar. So when we have a section, if I give you a section, and let's say I have this section here, and I'm placing some rebar. Should I make my rebar very, very close to each other? Like so, let me zoom in. Should I make my rebar this way? Does it work or it doesn't, please? What do you
It
No.
think?
doesn't work. It doesn't work.
Guys, don't ever forget, although we changed our topic, we went from beam to column, but the idea is the same. We have seen the same problem in beams. If we make our bars very close, there is a problem with concrete to flow in between. And what's the rule? You can see. Is that any different from beams? If you remember, how do we
No.
find the minimum spacing between the bar? Simply, it is 1.4 the bar diameter, or 1.4 the aggregate size, or minimum 30 millimeter. So you can tell here there is no change between columns in the beam. We must allow here for a minimum distance or spacing between the bars. Okay.
It makes sense because otherwise, how can the concrete penetrate to the rebars and no bonding if they're
Cover,
close
yeah,
to each
exactly.
other?
Covers the rebar. Now, how about the maximum? So let's go to the other extreme. So that's the minimum. How about the maximum? So what if I simply have 2 bars, like let's say this way. I have another bar here. Does the code have any limit on the clear spacing, like from this point to this point here? So this
No.
point here, it should be less than 500 mil. So the
Ah,
code says you can add rebar with a maximum spacing of 500. Does not exceed 500, and this is 7.4.1.3. The maximum spacing is 500. And does it remind you of something like this 500? Does it resonate to you? That's the same in the slab. In the slab, you cannot space the rebar in slabs more than 3 times the H, the thickness of the slab, or maximum 500 mil. Okay. Now, there are still more few conditions and requirements from the code, but these are for the ties. Okay. So, I mean, we finished already the requirement for the vertical bars. For the ties here, there are some requirements. Number one is the tie diameter. Like what is the size of the tie? Like, should we use 10 m, 15 m? So the rules are as follows. It says here, ties must have diameter of at least 30% of bars up to 30 m. Let's try to give you an example. Let's say I have a 20 m. So the vertical bars are 20 m. So what happened is we take 30% of that, and what happened is it will be 6 millimeters. Do we have any bars available in Canada here that is 6 millimeter?
no.
No.
No, as far as I know, nothing. So which means, according to this clause, it means my 10 m, my tie will be 10 m. And then even it says in the next clause, it says 10 m or larger for bars over 30 m. 10 m or larger for 30 m. So I think we can resolve this class here. Our ties all the time will be 10 m. Is that clear? So the
Yeah.
ties, just like the stirrup, huh? So the ties in our class will be 10 m. That's the diameter. Number two, and if you're following, you will ask yourself, then what is the spacing? What should be the tie spacing? So in the code in 7.6.5.2, it says tie spacing must not exceed the least or the minimum of 4 different numbers. So you have to estimate 4 numbers, pick the minimum, and this will be the maximum spacing between the ties. Number one, you just multiply 16 multiplied by the smallest vertical bar. So if, for example, if your bars are 20 m, then you take your 20 m, multiply by 16, and guess what? you will get here 320 millimeters. So 16 times the vertical bar. Number two, you multiply 48 times the tie diameter. And we just said that our tie in our class is 10 m. So which means this number will be 480 millimeter. And then the third number is the least lateral dimension of your compression member. Let's say my column is 300 by 500, which means this number is, let's say my column is 300 by 600, which means here this number is equal to 300, which is the minimum column dimension. And then finally, the last number is if you have bundled bars like bars, they are brought together. And I know that maybe some of you are not following. So bundled bars mean this, huh? It means this bar and this bar here and this bar here, we make them as a bundle, huh? And so we don't have to, we allow zero spacing. We put them close to each other, right? And this is called the bundled bar. And this is not really very typical in our, we always leave a spacing. We always only need it if we have a very, 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 very heavy reinforcement. Let's say you were working a bridge girder, so you bundle the bar together. So please ignore this one in my class. So I'm going to get rid of this guy here. So for bundled bars, then it's 300 mil. Now, let me ask you, we have three numbers, 320, 480, and 300. Which one should I use? I should use the least of them, which means finally your tie should be at 300 millimeter on center. Okay? Is that clear?
Does it always govern?
Sorry?
That the less lateral dimension of the compression member, does it always govern?
In most cases, yes. In most cases, yes. But
Okay.
let's say your column is a square. Let's say we solved already this morning that this column, which is 500 by 500. This morning we had this example 500 by 500. It's 500 by 500. It means this number is 500, and it means if this is 500 mil, it means this number will govern here 320, which is 16 bar diameter. Okay, are you following? So
Yeah,
bottom
okay.
line is we need to estimate the three of them. We need to estimate 16 times the diameter of the smallest vertical bar, or 48 times the tie diameter, or finally the least of lateral column compression member dimension. Okay, we estimate the three of them, then we take the minimum of them, and this will be the maximum spacing between the ties. Okay, now you guys know, same as this, do you guys remember the discussion for the stirrup when we talked about the hook? Like the hook can be 135 degrees or can be 90.
Yeah, I remember.
Yes, yeah.
This is very close. That's not very long time ago. I can tell you, please. You know, it says here 90. To be honest, I would simply cancel this guy. I would never, never, ever, as a designer or engineer, will never do 90 degrees, especially in columns. You guys know what is the function of the tie? The tie is confinement. It confines your vertical bars from buckling out to the outside of your column. And looks like the tie will have lots of tension force. Would you agree? Okay. And if it has lots of tension force, would you recommend the 90 degrees hook? I would never do that.
Never.
I will always simply go with 135 degrees. And I'm gonna remind you, I'll quickly go back and show you this failure so you guys appreciate what I'm saying. Okay, do you remember this picture here?
Yeah.
This picture, it will simply convince you of what I said. You need to have 135 degrees hook, and this will make a good anchorage because your tie will have lots of tension force because those members are trying to go to the outside, trying to buckle to the outside. Okay.
So Tahir, what if we use the 180-degree hook?
Uh, it's not that, it's not for columns. I know it's more efficient, but 135 is good enough. Like you're thinking to bend this guy and come back here, and bend this guy and come back here. It will do the same thing as 135. As long as, remember, I said that every hook with a different angle, it needs a minimum length of a straight hook. Okay, so if you remember 4 the bar diameter, or 6 the bar diameter, or 12 bar diameter, minimum 2.5 inches. Not sure if you remember this discussion. As long as you provide 6 the bar diameter, which is 60 millimeter, and I said 2.5 inches minimum, so 65 mil. If you provide 65 mil, it will give you the required anchorage into your concrete. Okay. Now, this one here, it is the last clause. That's the last requirement of the tie. And I would say one of the most difficult to explain to my students. Okay. So I'm going to give you kind of introduction to, and we already went through it and we know about it. We said this already. For a circular column, this clause doesn't apply. If you have a column which is simply circular column. So if the column is circular, and of course if the column is circular, then our tie will be circular tie. In this case, all the bars are trying to go out, and the force applied to the tie is tension, and so there is no bending at all. If you guys remember, if all the bars are trying to go to the outside like so, it looks like a tank filled with some liquid, and so the tension force, the tie works like a ring, and simply it will have a tension force. Ties are fantastic when it comes tension force. Really, they have problem with bending because they are tiny. A 10M bars, it's tiny. If you remember, I said about your hair strand. Take one of your hair strand, try to bend it, it's easy. Try to cut it in tension, snap it, it's very hard. Okay, same thing here. So this discussion, please understand, it applies on square or rectangular columns, not on a circular column. Because in a circular column, as I said, the tie will have a pure tension force, and it's fantastic. It's going to do it. It will confine all the rebar. However, let me take you through this problem here. Now, we know that the function of the tie mainly is not for shear, is to confine the vertical bars, not to buckle on the full length, which means we know that this bar wants to go this way, and this guy wants to go this way, same here, and then same over there, and this guy is trying to go this way, and this guy is trying to go this way. Would you agree?
Yeah, I would agree.
Yes.
Okay, so now forget about the vertical. That's not our topic right now. Our topic is the tie. What's happening to the tie right now if these bars are trying to go with those red arrows? What do you think? Is it going to be under bending or under bending plus tension?
Bending.
So the
It
corner
will
bars,
bend.
for sure, the corner bars, they cause tension. Look at this, the corner bars, they cause tension to your tie. The problem is those bars along the side. So one more time, the corner bars, so they apply tension to your tie. And tie is good, really good in tension. Really what causes the problem is those bars along the edge. Because when you think about it, you will see the tie will simply work as simple beam between. So we have a support point here for the tie. So the tie is supported here, and the tie is also supported here. In between, it will do like this. It will do like this between these points. It will do like this. I'm gonna exaggerate a little bit and to show you what's happening to the tie. Let's do this way. Okay, so the tie will do this. It will bend in between the corners. Okay, and so as I said, is the tie good in bending?
No.
No, it is not good because simply it's made out of 10M and it's so weak. So that's why here is the trick. The trick is the code is asking you, okay, well, if the tie is weak, how can we stop this guy from going outside? If we said that this tie is weak, how can we stop this guy from movement this way, simply we may need to add an extra little bit of tie here, and this tie here, what it does, it keeps this in place. Okay, I don't have the right tool, but think about it this way. I'm going to add a tie that wraps around those bars and simply hold them in place, prevent them from going outside. Are you guys able to visualize this?
Yeah, yeah.
Okay, now
Makes sense.
you can tell once I add this extra tie, what it does, it simply stops those two bars from going to the outside or buckling to the outside, because simply this tie is weak. Now the code have a kind of limitation, because remember, the longer the span, as I said, the tie is bending between the corner, and simply the longer the span between the support point, the weaker the tie. The longer the span between those support points, the weaker the tie. So the secret number is 150 millimeter. So the secret number is here. This is the secret number. So the code said, you know what? If this distance between the unsupported bar to the nearest supported bar is less than 150 mils, then it should be okay. You don't have to provide extra lateral support for your rebar. One more time. You can think about it. The longer the span between the support point, remember, the tie is acting as kind of a simple beam underbending between the 2 points. The longer the span, the weaker the tie. It means it cannot do anything to help this bar here from buckling to the outside. So bottom line is, when this is so long, it means it's very weak, and then we have to add this red extra piece when the secret number is 150, which means if we're able to estimate this number, which is not really a super science, it's based on geometry, I'm going to show you in a minute, then what we do is we simply if it's less than 150, then it's okay. You know, our tie is short enough. It can simply stop this guy from going outside. However, if this distance is more than 150, no, the span is too long, the tie is so weak, and we have to provide an extra support for this guy. So not necessarily that all the time I will need this extra support. Not necessarily. It depends totally on this distance here. Okay. And so what happens here on the right side, there is another example where we have many bars. We have one on the side, we have one, we have two, and we have three. Now the question is, do we need to support all of them? Do we need to support all of them? Here is the answer. Okay. So looks like, I mean, forget about this one. So initially you don't have this guy. So this extra tie looks like a diamond. Think about it as doesn't exist. Now, if you question, is my tie, the exterior ring here, is enough? Yes or no? Let's do it. So what you have to do is you look at the distance from this bar here to this bar here. Okay? Because again, this one is unsupported. I'm sorry. This one here is unsupported, and so this one is unsupported, so it doesn't help this guy, and this one is unsupported, so it also doesn't help this guy here. So really what helps this guy is this one which is supported here, and because of this distance exceeds our 150, and so then no, we have to add something. We cannot just use the exterior tie to do it. But please let me ask you, what if we add this diamond ring? What if we add this diamond tie? What if we add this one? So I'm asking you, when we add this diamond ring, what does it support? Obviously, this guy right now cannot go this way, can it?
No.
No,
It can't. It cannot go anywhere because of this diamond ring. And so, which means this guy right now became restrained. It became supported. And now what I can do is I can go and ask myself, now let's go from here to this guy. As long as this distance is less than 150, it means we're okay. It means we don't have to add anything to those unsupported bars, because simply the tie is simply short enough and strong enough. Okay, hopefully this convinces you, and we will have numerical example later on. Now finally, for concrete cover, okay, so there are some different covers. Sometimes we use 30 or 40 or 60 or 75. It depends on what? It depends on the exposure. And it's not really, it's a new discussion. We've seen this discussion when we talked about beams. Same thing. When I am surrounded by aggressive environment, looks like I will need to add more cover to protect my rebar. Really, what I want you to pay attention is this one here. So this one here, if I'm putting concrete against bare soil, so it means my soil is my form, then in this case, you must provide 3 inches of concrete cover. Are you following? When sometimes my column, we have a sonotube. Sometimes I put like wood forms. Sometimes I add steel forms. It doesn't matter. But in this case, it's not against the bare soil. If I'm doing piles, like, which means, remember how we do the piles, we get the rig, we make the hole with the diameter of the pile, and then we drop the cage, and then we pour concrete. So in this case, the concrete is poured against soil. In this case, you must provide 75 millimeter or 3 inches of clear concrete cover. Hopefully this is clear. Now, final recommendation or this practical design guidelines about the column, about dimension. I think also this is not new. We talked before about when we build beams, we cannot really make our beams any dimension we like. You cannot make a beam with 100 millimeter width. Very, very tight. Doesn't work. You cannot provide the cover and the tie and how many bars and spacing. And that's why I think I proved it for you before that the minimum is 200, and even 200 is only theoretical. Practically, the minimum is 250. And you can tell here 250, that's the minimum. That's exactly what I said on my slide. And 300 millimeter for circular column. Okay. How we go about rounding? So we always use multiple of 50 millimeter. So we make our columns 250, 300, 350, 400, 450, and so on. So we always make the next 50 millimeter. Okay. We don't change the column dimension so often. If you're building a high-rise building, which is, let's say, 45 floors or 50 floors, do we change column dimension every floor?
No, no.
We don't do that. So there is a rule that designer, again, it's not a Bible, like, you can do whatever you like, but practically you should change your column dimension every 3 to 4 floors. Okay, it's easier for construction, easier for forms. Okay, every 3 to 4 floors. Even it's not required the size, but you need to keep your column dimension the same for 4 floors, and then it changes and so on and so forth. The bars for the ties, as I said before, not new, the 10M ties. And then finally, for the vertical bars, please don't tell me I'm going to use a 10M for vertical bars. And hopefully you know why. So can we use 10M for vertical bars?
For columns, no.
Never, ever do that. That's a silly. The 10M are very tiny bars, and they will buckle. Even you meet all the requirement, still doesn't work. Even for 15M is so weak. So the minimum is 20M for vertical bars. Remember, I'm not talking about ties. I'm talking about vertical bars in your column. Okay. And so 10M for ties and 20M minimum for vertical bars. Okay. And then here is some column, shapes. Probably you've seen some of them. This one is very typical with like only 4 bars. And if we add 4 bars, more than 4 bars, for example, in this case, we have 8 bars, but the distance here from here to there, for sure it was more than 150, if you agree, huh? So this is more than 150, and that's why, because it's more than 150, what happened is we had to add this diamond bar. You can tell if we have more bars, then and we have to check the spacing, and if we need to restrain all those bars, we will do that. Really, what I don't like is this one. To be honest, I am not really big fan of those guys. Anybody has experience will tell me I agree. You know why I hate this configuration here?
Why don't you like it, Tahir? I've seen them a few times, but not very often.
Those are, look, Gord, those are very, very weak. Always fall down when you finish when you pour your concrete. Always. This here called hairpin. Okay, it's it's very weak and very hard. Really, what's better for me, whether I go with this one. So this one is my way to go. Is very well. You can tie it very well to your cage, but this one is very weak. Mostly those guys will fall down during construction.
Well, depends also maybe the angle of your hook. Depends on the angle of your hook. So if you make it
I
more a little bit tighter, then it will not fall.
I doubt those are very weak. I doubt I've seen them on site. They always problem. Okay. Okay. So again, for sake of time, my voice is raw is itching, but to be honest, I want to push a little bit harder to get things done tomorrow or maybe at maximum Monday, because my promise to you is to give you kind of 1 week off at the very end if I can do that. So just kind of started this one here, and this discussion shouldn't be too hard for you because you already have done your steel course. Okay, you have done your steel course, and the buckling is not really a brand new for you. So in concrete, we will handle it differently, but still the idea is the same. The idea is columns or any member that's under compression, it suffers from a phenomena called buckling, which means it's instability, which means the axis of the column will be deformed and go off your design axis, and that causes eccentricity and causes extra bending moment. This is in simple term. Huh? So watch this, please. So here is your column. If you apply compression like so, so you apply compression here and this way, so you end up with this shape. So this is called I'm sorry, I have to probably do the opposite. So if you, oh my God, not very easy to draw on. So that this is what you end up if you apply compression to your member. What happen is you will have a deformed shape, and you will get some eccentricity here, which means instead of you applying axial force, you'll get extra bending moment, even you apply pure axial force because of the buckling. Okay, so again, this discussion is not really brand new. Really, what affects your buckling is this ratio here called slenderness ratio, and it tells you how slender is your member. How do we estimate this number? And typically, we refer this one as lambda. So we call this one typically we call it lambda, and probably you use the same name in steel, huh? Lambda equal
Strength of materials.
on strength of material. So the lambda is how you can estimate it from K multiplied by L unsupported divided by R. Okay, and every one of those is a separate discussion. So we will have discussion about the K, a discussion about the L sub U, and then discussion about the R. For now, I'll give you the name only, and then later on I'll explain on what does it mean physically. So the K is called K effective length factor. Okay, and it depends on the end condition. It depends on the end condition of the column. L unsupported is simply the distance between the lateral support point of your column. And then R is called the radius of gyration. Radius of gyration, which is a very well-known term, and it has to do with the geometry of your section. In steel, we estimate the R equal to the square root of I over A, which is the moment of inertia divided by the area, and then we get the square root, okay? In concrete, we don't do that. In concrete, we don't do that. In concrete, we use a simplified equation. So in concrete, we use 30% of H if it's a rectangular or square column, and if it's a circular column, we use 25% of the D for circular column. Okay, so we're not using here same as we do for the steel. And I know some of you will wonder why, because concrete is non-homogeneous material. There is rebar and there is a steel, and my section could be cracked, and that's why it is not as easy as a steel with everything is a steel. So in our class here, we use radius of gyration is equal to 30% of the H or 25% of the D if it's a circular column, okay? And I think I will stop in here, and tomorrow we'll keep going on the same slide. For now, do you have any question?
No questions.
Okay, guys, we will have no question. And what happens? You can tell my my voice is so itchy, and I don't think I can teach you the next class. So I have a recording from yesterday. I will just let you watch the videos, and then we'll come back at the last 10 minutes to ask if there is any question. Okay, so take a rest for 10 minutes, and then I will give you here the links for the videos for the GIS board. I apologize for that, but I just can't. Thank you.
Thank you, Tahir.
No problem. Have a good day.